Okay, so today I want to go over not only the regression equations homework, the one that I gave you time in class Friday, right? Vaughn Parker, I gave you time in class on Friday to do. Get that out. Okay. And we're going to go through the homework or the answers, okay? And then we're going to jump straight from this into those two review pieces of paper. I gave you one on Friday, and then of course one I just gave you. And it's available on Classroom after I've uploaded the video for the people who are gone. So, number one, when you graph this, you should have definitely seen that it was a quadratic. Now, here's the two that make a bigger difference on your graph if you round, or even on your predicted values if you round. Quadratics and exponentials. So, for example, I had several people who, when they went and ran a quadratic regression, remember quad reg? When they went and ran that, they rounded their A value to like negative 0.01. And it's not that that's wrong, but whenever you're taking that and you're multiplying by x squared, the more you round, the bigger discrepancy it gives you in any of your future predicted values. You understand what I'm saying? So be careful not to over round. I said that on Wednesday when we went over this. I said it again on Friday. Be careful not to over round. So I went with negative 0.0084 x squared. And then I went with plus 0.752 x. And then I went with plus 13.553. And it's very rare that our values on the N2 would be different. But that first one, big difference in the way some of you guys may have rounded. So if you got close to that, the predicted value you would get for a car traveling at 35 miles per hour is 29.6. You should be pretty close to 29.6. If you're not close to 29.6, again, it's just how you rounded differently. All right, what'd y'all get on number 2? Huh? Yes, it was a logarithm. It was definitely a logarithm. It definitely started by kind of going up, and then it kind of flattened out. That's a logarithm right there. So that's what this one looked like. So our equation, when we ran our log reg, actually it was not log reg, it's ln reg. That's logarithmic reg. We talked about that. So you should have gotten pretty close to the same thing I got. 7.396 plus 6.19 ln of x. And therefore, since our values should have been really close, you should have estimated a baby's weight at 14 months to be about 23.7 pounds. Okay? Our values should have been very close on that one. Very close. Now, same for number 3 and 4. If you were here on Friday, which I think everybody said they were, I asked you guys on 3 to do years from 19 or from 2000. And I asked you to do on number 4, years from 1890. If you use the same years from that I do, our values should have been very, very close to the same thing. Very close. So what did y'all get on number 3? Yes, it was definitely linear. So if you run a lin reg, L-I-N reg, you should have gotten the equation approximately 2.23x minus 17.32. And I mean, listen, if you use years from 2000 just like I did, they should have been very close to the same. Very close. So our predicted value should have all been very close to 27.3. Okay? All right, last one. Again, you were supposed to do years from 1890. If you did that correctly, it told you what to run, right? It told you to run a what? An exponential regression. So x reg when you do stat calculate. And if you did that correctly, you should have gotten somewhere around 2.56 times 1.019 raised to the x power. It's crazy how much I can feel the storm in my head as I've gotten older.
Bro, what?
Like I feel the pressure.
Really?
I promise, it's weird. I felt it all morning long.
Can you smell the rain coming?
I just felt the pressure.
I swear you can actually smell it.
No, I know you can smell rain, but I didn't smell it. I just felt the pressure. It's like the barometric pressure is in my head this morning. I know it sounds crazy, but I promise you, I can feel it.
Stuff like that all the time. I think it's just once you get older, you just start coming ridiculous stuff.
Oh, I got like dementia or something.
So your predicted value in year 2022, which you should have used 132, because that's how many years that is from 1890. You should have gotten about 30.7. So I saw some close values. And by close, I mean I think Izzy's you said 34.6. That's close. I mean, we're going to round differently. And when you're raising something to the 132nd power, it's multiplying by that thing 132 times. It's going to make big differences in what we get. Like you probably rounded to what, 1.02? So you literally use 1.02 and I use 1.019. That's 0.001 different. But it made the difference of 30.7 to 34.6. So that's why rounding is so important. Okay, don't over round, okay? Because 1.02 is fine, but it still made that big of a difference. You see what I'm saying? So just be aware. So that's how you do regression equations. There is one on the review. There is one on the test. Okay? So let's go ahead and get that review out. We're going to jump right in.
Which one? The one you gave us today?
The one I gave you Friday.
Statistics review.
Get both of them out. We're literally going to go right in from one to the other. I have them actually labeled. The first one I gave you yesterday is 1 through 10. And then the one I gave you today is 11 through 20. But some of those are so fast. Listen, what you see right here is what you're going to get. I think there's going to be 17 problems on the test itself. And I'll explain where that discrepancy comes in just a few minutes. Okay? There's 20 on the review. I think there's 17 on the actual test. So, some of this goes way back to probability, which is what we actually did at the very end of last 9 weeks. And then, of course, the rest of it's statistics. So, first of all, let's start with a probability something. This was what we started with when we started our probability and statistics unit. Comparing observational studies to experiments. Do y'all remember the big difference? What's the big difference between experiment and observational study?
One you're actually doing, one you're just observing.
Yes. Experiments, I actually control the treatment. I do. If I'm running the experiment, I'm running the treatment. So you have to read these questions from the mindset of, hey, am I controlling the treatment or is the treatment just happening and I'm watching it? You understand the difference? So look at this one. It says you want to know if reading to children every night before bed affects the age they begin reading on their own. You choose families who read to their children every night before bed and choose families who do not. You record the age children in each group begin reading on their own and you compare. Guys, am I controlling the treatment or is the treatment just happening and I'm watching?
You're watching one.
So this is definitely a observational study. Now, in my opinion, if you ask that question, hey, am I providing the treatment or is the treatment just happening and I'm watching? It is very clear on this problem. I promise it will be just as clear tomorrow on whether it's an observational study or an experiment. If you ask that question, am I applying the treatment or is the treatment just being applied and I'm watching? You see what I'm saying? That's the question you need to ask yourself to make that easy. Okay, number 2 through 4. Now listen, I am giving you a reference sheet tomorrow. Why? Because it has 2 formulas on it that are possibly needed. This one, and then also Z-score. Z-score is your x minus your mean divided by your standard deviation. Has it all written out just like that. You're going to need it. So, with that being said, you don't have to memorize the numbers I'm about to tell you, but I think it makes it easier if you do. Here are those numbers. Those big categories right in the middle. Remember what those are? They're 34% each. Y'all remember what the next little slivers are? They're 13.5s. Y'all remember what the next little percentages are? 2.35s. And y'all remember what the smallest little slivers are? They're 0.15s. 0.15s. I would recommend you memorize those. If you can't, you can utilize this. Think about it. It's telling me that these standard deviations are 68. Well, what's 68 divided by 2? 34. It's telling you two standard deviations 95. What's 95 minus 68 divided by 2? 13.5. It tells me that these three standard deviations is 99.7. So 99.7 minus 95 is 4.7 divided by 2, 2.35s. And then you have 0.3 left to divide by 2, that's 0.15. So that tells it to you if you don't memorize them. But I think memorizing them makes it easier, personally. Your call. Now, if you read the problem, the number of days a group of 250 homes is on the market is normally distributed with a mean of 50 and a standard deviation of 13. Guys, what do I do with that 50? I put it right smack dab in the middle. What do I do with that standard deviation of 13? I add it and subtract it. Let's add it to the right. Ready? What's 50 plus 13? What's 63 plus 13? Plus 13? Let's go the other direction. What's 50 minus 13? 37 minus 13. 24 minus 13. All right, Vaughn, phone away. In fact, it's about to be mine. Oh, wait, not in your lap. All right, now there's two types of questions that get asked here. One, it's going to say, what's the percent or what's the probability? If it asks what's the percent or the probability, you give the percent. The other question is going to be like, hey, how many homes? How many, whatever it's talking about. So, there we have to think a little bit further. Let me go through these with you. Ready? Number 2. What percent of homes are on the market between 11, here's 11, and 89? I got to highlight quite a bit to get all the way over here to 89. Isn't that 3 standard deviations? So you can either remember that that's 3 standard deviations, or couldn't you just add all those up? Either way, what do you get? You get 99.7%. Questions? Let's do the next one then. What is the probability? See, same question. Percent, what is probability? Same question. That a home is on the market for at least 37 days. What does at least mean?
A minimum of 37.
So 37 and up. So that's all of that. Now, y'all know, what's from the middle to the right over? Isn't that 50%? So isn't that just 50 plus 34? What's 50 plus 34?
84.
84%. You could have added all those up, or you could have went 50 plus 34. I don't care. Your call. Whatever you have to do to get it right. Now, the last one's asked a little differently. It doesn't say what percent. It doesn't say what's the probability. It says approximately how many homes. Approximately how many homes are on the market between 37, here's 37, and 63. Now, what percent of homes is that? That's 68%. It doesn't ask me what the percent is, does it? It asks me how many homes is that? Well, it's 68%, guys. That's 0.68. It's 68% of times what? Nuh-uh.
250.
Why 250? Because that's how many homes there were. And 68% of those homes lie between 37 and 63. So 68%, 0.68 times 250 will give me my value, which is 170 homes. Now listen to me real carefully, y'all. Listen. Tomorrow, if you get the same type of problem, let's say the value ends up being 170.6. I would accept 170 or 171 because I do understand that 170.6 does round up to 171, but some people get stuck on the fact that you can't have 0.6 homes, and I agree with that. So I would have accepted 170 or 171. I won't accept 182. You get what I'm saying? It's got to be between those values if it's a decimal. If it's not a decimal, it's a number like that. That's my expectation. You would have gotten 170. All right, moving on. Number 5, and just like this on the test, guys, I would just use the graph that's already done for you above. This time, the wind speeds throughout the month of April were normally distributed with a mean of what? 17. Where do I put that 17? Right in the middle. And a standard deviation of what? 4. So guys, let's add and subtract 4. Ready? I'm going back up to that same diagram. What's 17 minus 4? 13 minus 4? 9. What's 9 minus 4? Okay, that's that direction. Let's go to the right. What's 17 plus 4? 21 plus 4? 25 plus 4? Okay, now, I don't have to reinvent the wheel. Let's just use the one that's already drawn for me, just like I did. Now, what's the question asked? What percent, not how many, what percent had wind speeds between 5 and 13? That's those two little slivers right there, isn't it? So that's 2.35 plus 13.5. What's 2.35 plus 13.5? 15.85%. Y'all good with the front side? Okay, let's flip over to the back then. Let's flip over to the back. Or erase that so I don't have to worry about it later. Let's grab our calculators. What should you do when you first get your calculator tomorrow?
Factory reset.
Yep. You could reset that calculator. So let's do that. Second, plus 712. Let me clear all these key presses out. Now listen to me. I promise you I won't give you a years from tomorrow. There'll be no years from. There'll be no years. It'll just be the values that you get, you can enter them. Just like this one, okay? So where do we go to enter them? Stat, edit. Here we go. 1, not 11, Brad. 1, 2, 3, 4, 5. You'll get to enter them just like you are getting to enter these. 4, 6.8, 8.1, 9, and 9.5. Okay, now do y'all remember what to do next? We got to see this. Well, this is my stat plot. We want to turn our stat plot on. Guys, if you call me to your desk tomorrow and say, hey, I can't remember how to do this, I'm just going to have to turn around and walk away. You can memorize this. We've done it. You practiced it. I'm going over it again now. How do I turn my stat plot on? Second, y equals, and you just push enter a couple times. Now my stat plot's on. But we got to tell our calculator to zoom in on the stats, remember? How do we tell our calculator to zoom in on the stats? We do zoom, and you can either scroll down until you see zoom stat, or you can remember that it's number 9. Now, this is your job to determine what is that. Is that a line? It's a little curvy to your line, isn't it? Is it a quadratic? Does it turn back down? If it does, I don't get to see it. So I can't predict that it's going to. Is it exponential? Does it start flat and then go up real high? Does it start by coming straight down and then flattening out? No, it starts by going up and then flattening out. That's a logarithm. So this is a logarithm. I'm going to write it real quick. We'll go back to our calculator in a second. Logarithm. Then we have to find the equation, right? Remind me, where do I go in my calculator to now find the equation for this logarithmic function? Stat, calc, and then here are my possibilities. A line, a quadratic, a logarithmic, an exponential. So we definitely want to do a logarithmic one. So we push enter a bunch on it until finally it writes the equation for me. Ready? Y equals, what do y'all like A to be? 4.18. 4.18? Yeah, 4.18 looks good to me. Plus B, what's B? 3.45 maybe? And then the equation says ln of x. So there it is. Here's my equation, y'all. It's a logarithm. Y equals 4.18 plus 3.45 ln of x. I'll come back to that in a second. I like to go graph it. You don't have to go graph it, but I like to make sure it's a really good representation. Here's ln right here. You see my cursor wiggling? There's ln of x. So here we go. Enter. And let's graph this thing. Oh, yeah. That's a nice representation. In fact, it touches every point. So what's the last thing number 8 asked me to do? Find the height when the tree is 15 years old. So I'm going to go plug 15 in. Ready? Go back to a second quick. Go back to your home screen and do 4.18 plus 3.45 times the ln of 15. About how high is it say it's going to be? 13 and a half feet. And that's all there is to it, y'all. Questions about that? Can y'all do that tomorrow?
No.
Well, you need to figure it out between now and then. Figure it out between now and then. All right, number 9 might be the easiest problem I've ever given you. We talked about this thing. It's called margin of error. Here's what I called it when I taught it. I said margin of error takes a mean for a sample and it applies it to the mean of the population. And when it does that, margin of error gives you a little wiggle room. That's what I called it. You got a little wiggle room. Well, if the mean here is 515 and the margin of error is 10, how do I use that 10 to give me wiggle room? You subtract and you add it to 515. So what is 515 minus 10? 505. And what's 515 plus 10? So my value with the 10 pound margin of error is 505 to 525. Can y'all miss that tomorrow on a test? You better not. Last problem on this side, ask about the population proportion of your least preferred subject. So let's start with that. What is my least preferred subject?
Math.
Nope. It's science on here. All right, it's science, 16. Y'all remember how we make a proportion? We set it up as a fraction. What do you think we put 16 over? The total. 16 over the total. How do we find the total? 20 plus 30 plus 16 plus 45 plus 34 is 145. Now read the instructions. It tells you what to do, doesn't it? Give the answer as a decimal rounded to 2 decimal places. So please go type that in your calculator for me. What's 16 divided by 145?
Wait, 11.
To 2 decimal places. 2 decimal places. Really? Y'all gonna just let her do it and then y'all are gonna try it? It's 0.11. Read the instructions. It'll say the same
I
thing.
was confused because that's what Nevaeh said.
Yeah.
I thought you said 0.1.
Yeah, no, I thought I said
You said 0.11? I'm sorry. I only heard 1.
I was like, I did it right.
I only heard you say 1.
I
1.
said 0.11.
My bad.
It's good.
I misheard you. That's my fault. Old ears. Right, Vaughn?
It's the weather.
Yeah.
It is. I'm telling you, the barometric pressure is causing me problems today. Okay, so let's go to the other one I gave you. And let's start with these first 6 problems. But how many can you do just straight calculator? 4 of them. 4 of them you can do straight calculator. So first of all, let's start with our calculator. What are we going to do to run this data? Nope. Y'all haven't said it yet.
Reset.
Yes. Reset your calculator. Reset it. Now go to stat edit. Now let's enter these. Listen, don't be in such a rush you write something wrong. Literally in 3rd period today, when I was doing this, I entered a number wrong. It was the very last one. I put 85 instead of 65. Please be careful. 89. Double check it as you go. 77. 60. 100. 84. 93. 95. I'm going to stop talking. Just enter them. Enter them correctly, though. It wouldn't be a bad idea after you enter them just to go back through and make sure you got them all. When you double check it, then how do I run data on just one list? Go back to stat, calc, and we're running a 1 var stats. Okay, now let's just look through this list. What's this X bar right here, y'all? It's your mean. So my mean is 81.6. Okay, sum. What is this one? That's your standard deviation. So my standard deviation is 10.98. What else can we find here in this list? Right here, median is 82. Now, just a second ago, I told you you could find 4 of these with your calculator. Did I lie? I only see 3. Exactly. To find variance, is everybody hearing me? To find variance, we simply square standard deviation. So still with my calculator, 10.98 squared is 120.56. So I did find 4 of these with my graphing calculator. What's the one value I can't find with my graphing calculator? That's the one I can't find. Okay? Mode. Remember what mode is? Yeah, it's the one that's most frequently occurring. So here's what I do. I just start with 89. Y'all see 89 again? I don't either. How about 77? You see 77 again? Yeah, I see it here and here. How about 60? How about 100? 84? 93? 95? 78? 67? 90? 82? 81? 86? 65. So the only one that's repeated is, that's your mode. It's the only one you got to do with your own brain. You got me? Now, I'm thinking about taking this one off, but in case I don't, let me go through this. what are the values that I plug in one more time?
34. 13.5.
13.5, 2.35, and 0.15. Also, if we do this tomorrow from this data, what goes smack dab in the middle? 81.6, your mean. Now listen, because we're not going to add and subtract 10.98, I promise you we'll do the same thing tomorrow. We're going to use the rounded version of that 10.98, which is what? 11. So let's subtract and add 11. What's 81.6 minus 11? Minus 11? Minus 11? Let's go the other way. What's 81.6 plus 11? Plus 11? Plus 11? And there they are, okay? May give that to you as a bonus. We'll see. It may not be on there, or it may be on there as a bonus. But you should be able to do anyways, so should be 3 points for you. All right, last one. Again, last one comes, and every one of these questions are about z-score. And the z-score formula is literally on your reference sheet that I will be giving you. Okay? If you don't find it there and use it properly, that's on you. It's got 4 things on it: z, x, mean, standard deviation. Listen, I told you to be 17 problems. Here's why. Number 17, all 3 of those are z-score. I'll only give you one of those tomorrow. I mainly just did this to mess with Brady Darty, to show that his swing speed's slower than a girl's. He didn't even find it funny, which made me mad.
You only swing at 108.
No, I swing faster than that. I came up with these last night just messing around. Anyways, here's how this works. This problem asked me about z-score. What's the formula? What does it say? What's x?
94.
That's what he scored, 94. Minus, what does mean in this problem? It says 100. Divided by standard deviation, which just says what? So literally going to go to my calculator, guys, and I'm going to go alpha y equals, number 1, right, to get my fraction. And then I do 94 minus 100 over 3.6, and it's going to give me a z-score of negative 1.67. Y'all good with that? Now again, I don't even have to do the rest of them, do I? I was just messing with Brady. I can do them if you need me to. You want me to?
We're good.
All right. You do the same thing. You just replace the 94 with those values. We're going to have one of those tomorrow, where it asks you to find the z-score. You're going to have one tomorrow, like number 18, where it asks me how many pitches did Bo throw. Well, guys, think about it. If I'm dealing with Bo throwing pitches, which value is that I don't have? It's not the z-score. It's not the mean. It's not the standard deviation. It's the x. So let's look through this problem. What's z-score? Negative 2.2 equals, we don't know Bo's pitches. Minus, what's the mean though? 87. It told me. The mean was 87 with a standard deviation of 3.2. So I'm trying to find x. You follow? Now solving this problem should not be hard for you guys. Don't I need to get rid of that 3.2? How do I get rid of that 3.2? So go negative 2.2 times 3.2. And that equals x minus 87. Guys, once again, how do I solve for x? Add 87. So negative 7.04 plus 87 is 79.96. Vaughn, can I throw 79.96 throws?
No,
So how many throws did Bo throw?
80.
He threw 80. Okay? 80 pitches. Pretty good outing.
How many innings did he throw?
He complete game. CG'd it.
Oh, CG with 80 pitches, yeah.
Yeah.
Real good, real good.
That was his night the other night.
No,
Look
he
at that
threw-
CG.
Yeah, he threw a CG, but was it 80?
I don't know. I'm just making that up.
I was keeping pitch count though.
Oh, good. You did a bad job remembering. Okay, look at number 19. It says a set of papers is normally distributed with a standard deviation of 5. Right? If Jared scored a 92, what do you think that is? If Jared scored a 92, that's right here. That's X. Jared scored a 92 with a Z score of 2.2. What am I trying to find? What do I not have? I don't have mean. So here we go. Z scored. What's Z score? 2.2 equals X. What Jared score, y'all?
92.
Minus the mean. I don't have it. Divided by standard deviation, which is. So there it is. Now I use mu to stand for the mean. Whatever you want to put there is fine. Put an M for all I care. Literally spell the word mean for all I care. That's what your formula will say. Now, here we go. How do I solve this problem? 2.2 times 5 is? So 11 equals 92 minus mu. Minus me. Now think about it. Don't I need to move the 92? What's 11 minus 92? So negative 81 equals negative mean. But we know we're going to move that negative over. So my answer is what? 81 is the mean. Y'all with me? Last problem. Look at what I got. The heights of a group of trees is normally distributed with a mean of 14.6.
Okay.
A mean of 14.6. If the Z-score for an 18-foot tree, wait, what's an 18-foot tree about? That's X. If the Z-score is 1.4, find the standard deviation. So here we go. Z is 1.4, and that equals X, that's your 18-foot tree, minus the mean, 14.6, divided by, which I'm just going to use that little sigma. Now, think about it. We've been getting rid of that fraction by, so let's do the same thing. What is 1.4 times standard deviation? And then what do I do with 18 minus 14.6? What is 18 minus 14.6? And what do I do lastly to get the standard deviation alone? So 3.4 divided by 1.4 is approximately 2.43 standard deviation. That formula is given. You don't have to memorize it. Any questions? Test this tomorrow. I hope you guys prepare and do well.